So let's say, we want to deal with 5 volts. I like 5 volts, and it's what I have connected up here, so we'll go with that.
And most Arduinos are 5 volts.
Yes, the circuit level logic and the voltage that you'll see on all the pins is going to be 5 volts for the standard Arduino. If you have not seen one, there's one here, and I see several others out in the crowd, so take a look around, ask questions.
If you don't have one, you can buy one when the class starts.
Yes.
They're like 20 bucks.
Yeah.
Or you can buy it through us.
Yeah, we're gonna. So for those of you that are here in anticipation, yeah, for those of you that are here in anticipation of the class, there will be a fee associated with the ultimate class, but that will also include a whole bunch of stuff like these lights, resistors, a board, everything you need to get going. You won't need to bring anything. You can bring your computer if you want. We'll try to arrange something if you don't, but that should cover that. Anyway, back to this. Right, we have an LED, and let's say we just want to deal with the red one for now, right? Because I don't like any other colors right now. And red is fairly common, right? Everyone sees red LEDs. Well, red LEDs have a lower voltage, and they're generally 2 volts. Right? So if we have 2 volts being used by the LED, how much voltage are we going to have on the resistor?
5 divided by 2. So my math is just not registering today.
Not multiplication. Right? So something that I left out is that all of the voltages in a circuit, a simple circuit of just one cycle, have to add to the voltage of the battery. So we're actually going to have 3 volts on the resistor.
So everything in series then?
Yes, for now we're doing a basic, simple series circuit. For those of you that are curious, series just means in order. Right? The battery connects to the resistor, connects to the LED, connects back to the battery. Right, so we have a circuit, and we just have one path for that electricity to travel. We'll eventually get to multiple paths and how to do all of that. It's slightly more complicated, but not much. Right, so if we have 2 volts across the LED and 3 volts across the resistor. Now, the LED provides minimal resistance. Right, so you lose some voltage, but you don't impede the current at all. So you could, it'll flow through. Yeah.
So then, the resistor assumes whatever voltage goes along with the other components?
Right. So the resistor is just that. It's a resisting force. Right. It slows things down.
So it doesn't have a set voltage, though.
Right. It can be used at a wide range of voltages. We will get into how resistors are limited. They're actually limited by the amount of power they dissipate, which is a whole other equation. But for now, let's not worry about that.
Just so no one's confused, the resistor is not rated for 3 volts. That's going to be our target for this particular circuit.
Right. So if we were to connect these up, then 3 volts will be going across this resistor. Now, I said I wanted 20 milliamps through my LED, because I know it can handle it, and I've checked the spec sheet, and I've looked, and it said, okay, this can have a current of 20 milliamps sustained and be fine. Right. So if I know I have 3 volts and I have 20 milliamps, right? Math time. Right. So 3 volts divided by, like I said, 20 milliamps, which is actually 0.02 amps. Right? So when you're doing calculations, you want to take into account the frequency. Right? So 20 milliamps, 20 milliamps is 0.020 amps. Right? You move the decimal over 3 spaces because it's 1,000 difference, million means 1,000, and we get 0.02. So 3 divided by 0.02 is 150, right? The resistor I have on here now is actually 560. So I can see if I have 150 milliamp or 150 ohm resistor. Oh, for those of you that are curious, the unit for measuring resistance is ohms, and it's drawn like the Greek symbol ohm. Right? Volts and amps. So current, like I said, is I, and the unit is amps. Voltage is V, and the unit is volts. Resistance is ohms, and you have the symbol of ohm. There will be many funky symbols throughout this course, and these get-togethers, and looking at product sheets.
Now the 20 milliamps was the
target current that we wanted. Right, so we picked 20 milliamps. Right, we picked this number as the current we wanted through our resistor,
But
and
is that
in turn also through our LED.
Would that be arbitrary then? Like
It would be based on the sheet. Also, you know, if this thing is going to be battery powered, you have to be aware of the current value, because the battery will only last so long. So batteries are actually, so smaller batteries are measured in milliamp hours, and that's exactly what it sounds like. So you divide by the number of milliamps, and that gives you how many hours you can use that amount of power, roughly.
The current also relates to how bright the LED will be.
Yes.
So if he used a bigger resistor and had less current going through the LED, it would be dimmer. If he put, you know, like maybe 100 milliamps through the LED, it might burn out. So that's why you want to pick the right resistor value, so you get the things, the brightness you want, and it doesn't burn out.
And the burning out would be on the data sheet of the LED.